Hey, welcome back everyone. So in the last video we discussed the addition of the data center to our topology here. So it was a big change, dedicated a whole video just to kind of discuss it. Well, we're now at the point where we're going to jump in and we're going to start to chip away at all the configurations here. So the way I see it is we're going to start with the core switches, okay? So and just a reminder, everything below the firewall is essentially going to be, for the moment, private IP address schemes, EIGRP routing, stuff like that. Everything above the firewall and above is going to be the public segment, if you will. So more BGP and pretty much public IPs at that point. This will be our NAT boundary, which is the firewall here. So we'll introduce NAT in this topology as well, or the data center, obviously. So yeah, we're gonna jump into the two cores. So I've just started those up. So they take a few minutes. The more Nexus 9Ks you introduce to the topology, the bigger server or more resources you're gonna need. So just be aware of that. Especially when you get into things like VXLAN, which is like all Nexus platform, it really starts to chew up resources. So I went ahead and booted them. I always disable the POPE or the power on auto provisioning. And then I always say no when it asks me to enforce the secure password. I say no on both. And then it allows you to put in the password for the admin account. In my case, I just use Cisco, all lowercase. So I'm going to go ahead and log in with admin, and you can see Cisco. Okay. So at this point we have two fresh Nexus 9K switches with nothing on them. I'm running 10.4.4. Okay, so that's the version of code I'm running. I believe there's some newer versions out. This isn't terribly old. I think I grabbed this a few months ago when I was doing my VXLAN stuff. So it should be fine for the purposes of what we're doing, but just to kind of show you what I've got, 9000V with the 10.4.4 NXOS code. So what we need to do here is I like to always start with our VPC domain and get these things to a point where we know that we can start to successfully bolt on other devices to the cores. When I say bolt on, I just mean wire in, right? So everything in the data center is going to have dual links, one to each core, and if the cores are not configured correctly, chances are you're going to have issues. So especially when you start to cable in layer 2 switches, stuff like that, like these top of rack switches that we're going to be playing with, what we're going to want to do is connect one cable to core 1, connect one cable to core 2, and we're going to configure an ether channel on that top of rack switch, or a port channel. But the idea is that top of rack switch thinks it's only connecting to one other device, but in reality it's connecting to two Nexus switches, hence the virtual port channel. So how do we configure that stuff? Let's just jump right in. So first things first, so we'll get the config on Nexus 1 first, and then we'll go back and forth, and we'll just make sure that we're not missing anything here. So let's give him a host name, DC Core 1, or DC1 Core 01. This command here, so if I were to power off these switches right now and restart them, it gets stuck at a boot menu or a boot prompt because it's looking for what version of code to boot into. So I'm just going to go ahead and tell it. I've got a little cheat sheet on the side here. I'm just going to grab the command. So what we want to tell it is to boot from, boot NXOS boot flash, and then we're going to tell it this. Okay, so that's the syntax we're going to want to use. So when you when you put that into the running config, it does a little verification and compatibility check. But once it passes that, the next time you reboot this, it won't ask you or present that boot prompt or the loader prompt, and it'll just boot right into this version of code. So. All right, so that should finish in a second. So what we're looking at, we have multiple connections between the cores themselves. So you might be asking yourself, why are there so many connections going between them? So I've seen this done multiple different ways. I've had several conversations with folks about, one way versus the other. What we're going to do is I have a config that I'm going to use that's, like I said, it's a variation of a couple. So we're going to choose some interfaces and we're going to dedicate them to a specific kind of function or role, if you will. So in order to make these switches a VPC pair, you have to have a VPC peer link that goes between the switches, and you have to have what they call a keep alive. So there's constant heartbeat going on between the switches, which is the keep alive. And then, you're going to have some kind of layer 2 trunk between the switches. And in some cases, or all cases, you may want to have a layer 3 link between the two switches for purposes of routing. So we're going to engulf all of those, and we're going to do it with 3 connections. And the big debate is how many connections you use to establish, those roles or those functions. Some people like to bundle some together and make port channels and then layer on the keep alive on top of a port channel. Same thing with the routing. The routing might be done between 2 loopbacks, and then you can route over some kind of connection, or you can do it with interface VLANs. Like I said, there's many, many different ways to accomplish it. So we'll just stick to kind of what I'm doing because I know that it works. I've used it in the past, and I haven't really had any issues with it. So in order to start to do these connections, right, like we are going to use a port channel in one instance. So let me just kind of show you something here, and then we'll actually get into the meat and potatoes of it. So if we go back to the topology, let's just say let me look at my notes here. So we're actually going to make 1.6 and 1.7 a port channel, okay? So 1.6 and 1.7 are going to become a port channel. If I were to go into interface eth 1/6, and I know I need to configure other things, but if I just try to type channel group 1 mode active, it says the LAC process needs to be started before configuring active or passive mode. Okay. So, like, what exactly does that mean? That means that the feature's not activated. Same thing, like, if I were to go in the interface VLAN, let's say, 999, it won't even allow me to do that. And it's kind of misleading, right? Like, it's like, well, why can't I do a switched virtual interface? This is a Nexus switch, for crying out loud. It's because the feature's not turned on. So, like, typically one of the first things you're going to want to do is turn the features on. So the features that we're going to need for the purposes of this video right now are these 3. So we're going to turn on feature LACP. That's going to be for our port channels. We're going to turn on feature VPC, which is for the virtual port channels. And we're going to turn on feature interface VLAN, which will be for the purposes of creating SVIs. Okay? So we're going to go ahead. We're going to do that on both switches. Alright, so those features are activated. I'm going to save myself the trouble, and I'm going to do the no IP domain lookup on both switches. So when we start to do trace routes, we're not waiting for domain or DNS name resolution. We've already done our host names. The next kind of homework item we're going to do is related to spanning tree. Okay, so if you've watched all these videos leading up until now, in the one branch site, we configured spanning tree on the first floor switch because we wanted to make sure it was the root of the spanning tree. It's important in the data center to consider the same thing. we're going to just say that we want DC1 core 01 to be the root of the spanning tree no matter what. So what we're going to do is we're going to type the command, spanning tree, up here. All right, spanning tree VLAN, and we can see if we use iOS help or Nexus help in this case, the amount of VLANs that this version supports is 1 through 3,967. So we're just going to say that for every single VLAN possible, okay, we're going to want the priority of this switch to, I'm just going to make it 4,096 because it tells us it wants it in increments of 4,096. So that tells me the first or the lowest would be potentially 4,096. So I'm going to go ahead and issue that command. Okay, so what that's going to do is that's going to always guarantee that my core 01 is going to be the root of the spanning tree for basically every VLAN. Okay, so it's a catch-all command that it's a fail-safe, and it's always going to prevent any other switch from overthrowing core 1 from being the root. So what we're going to do on core 2 is a similar command, but we're going to raise that priority, right? Because we know that the lower the priority, the better, the higher, the worse. So we're going to make core 2 worse than core 1, okay? So that should cover us in the future for any spanning tree gotchas as far as switches that we connect to these cores. All right, so I've decided that we're going to use a pretty recognizable VLAN for our keep alive for the VPC peer link. So what I'm going to do is I'm going to define VLAN 999 on both of these switches. So I'm going to create VLAN 999 and I'm going to give it the name keep alive. Okay, so it's very descriptive. I know exactly what that VLAN is going to do, and there's no question about it. Now the other thing that I've had some debates around is the keep alive does not necessarily need to be in a VRF as far as my understanding goes. But if you put it in a VRF, it can kind of keep it protected, because if that keep alive goes down, your VPC will go down between the switches and you will have major problems in your data center. So what I've seen a lot of people do is they create a VRF. Okay, in this case, I'm going to create a VRF called keep alive, okay, to match the VLAN, to keep it in check. I know exactly what this stuff does, all right? So we're going to define that VRF keep alive. Now we're going to create a switched virtual interface, or an SVI, and we're going to assign an IP address to it, and we're going to put it in the VRF keep alive. So what we do for that is we create interface VLAN 999, we no shut it, we put it in VRF keep alive, and we give it an IP address. Now, for those of you who know your subnetting and your RFC 1918s and all that, you know that this address is not a routable address. And the reason I chose it is because it's strictly going to be used for the keep alive. I don't need to use it for routing or switching in any way, shape, or form. And again, it's easily identifiable. So that's why I put things in caps. That's why I use kind of these weird IP address schemes, because I know that this isn't something that's connecting to another network device that's routing like, I shouldn't say it that way because it's not necessarily true, but it's got a specific function and role, and it doesn't need a real routable RFC 1918 IP address. So I'm giving it this because it's easy to see and identify as something that's important, if you will. And it goes into this VLAN 999, again, easily identifiable things. So we're going to do the same thing. So if we grab up to here, we're going to do the same thing on core 2, except he's going to get the .2 and he'll be a /30. Okay, so all that's telling it is .1 and .2 are in the same /30 subnet. They should be able to basically ping one another through the VRF keep alive. Okay, that's all we're trying to do here. Now the next step is we need to create what's called the VPC domain, and this is only needed on the core switches or any switches that are going to become a VPC pair. Okay, so in order to do that, we use the command VPC. We hit the question mark. We see domain, and then we have to give it a domain ID. So I'm going to call it 999 just to kind of match the VLAN that we're using for the communication between the switches. Okay. So I'm going to run that same command over here, and it should dump us into VPC domain configuration mode. Okay. So now if we hit the question mark, we have some options here. What we're going to specify is who's our peer switch, or this, you know, we're just going to say peer switch. Okay. In this case, we need to tell the VPC domain where's our peer switch located. How do we get to that peer switch? And this is a longer command, so what we're going to run here is we're going to say the peer keep alive, okay? The destination is the IP address that we just put on switch 2. So the destination's .2. The source, okay, is us, which is the 1.1, okay? And in our case, we're using VRF keep alive. Okay? So show run section domain. We see that we have VPC domain 999 peer switch with the keep alive command. Okay? So we need to run that same command on switch 2, but we just have to kind of reverse the IPs. So the destination is 1 in this case. The source is going to be 2. But that's still over VRF keep alive. Okay? So we've got that groundwork lead. Now we still need a couple more, there's still a few more things we need to do in order for that VPC to establish. Okay? We have to tell it the ports that we're going to use to have this communication between the switches. So in our case, we had the 3 crosslinks, 5, 6, and 7. So we're going to take 5. Okay, so we're going to go in the interface ETH 1/5, and we're going to say this is the description VPC keep alive. Okay, and we're just going to dump it in access VLAN 999. So only allow VLAN 999 to traverse interface 1/5 or Ethernet 1/5. Okay, that's all we're doing. We're trying to keep this as basic and as foolproof as possible. Okay, so we should be able to do the same exact thing over here. All right, so description VPC keep alive, and we're going to say switch port access VLAN 999. We'll just dump the switch port in there. I don't think it matters after we type the command, but just for good measure. Okay. So now if we did, like for instance, if we did a show interface status, we should see 1/5 is the keep alive. It's now belongs to VLAN 999. Okay. Just quick verification, just to make sure nothing goofy happened. All right. So now we need to tell it which of those that's for the keep alive. Now we have to tell it which interfaces are for the actual peer link, if you will. So we're going to use 6 and 7 for that. And we're going to put them in a port channel, not a virtual port channel for that matter, just a port channel. Okay. So what we'll do is we'll do both interfaces at the same time. So we'll do interface. I could probably do it for both actually. So we'll do interface ETH 1, 6 through 7. Okay. So we'll do like a range command, and we'll give the description here. VPC. We'll call it. Layer 2 peer link, okay? Because this is going to be a trunk, which is why I'm kind of calling it layer 2. This is going to be a trunk that allows VLANs to traverse between the switches, okay? So we know that we have to do switch port mode trunk, all right? And then in this case, like I said, we're going to do channel group 1 mode active, okay? So we're going to put that in port channel 1, all right? So what that should do is that should create, on Nexus, it's show port channel summary as opposed to ether channel summary. So a little bit of a syntax change there. But we can see that we've got channel group 1, it's switched, it's up, and the 2 ports are up in a port channel, which is the P. So that is a good sign. So we've got a working port channel between both switches. All right, but now we have to put put attributes on the port channel 1 itself. Same as we did in the old layer 2 versions of Catalyst code, if you will, right? So show run interface port channel 1. All we've got on there right now is the trunk because Nexus OS created that interface for us, but it didn't put the commands on there that we necessarily need or want, okay? So we're going to give it a description. So we'll call it the VPC peer link, okay? We're going to make it a switch port. We're going to say switch port mode trunk. We might as well just do the spanning tree port type network like we did in our earlier videos, okay? So we can do that. Here's the key piece. The key piece is, and I'll use help so you can see, there is a command called VPC for virtual port channel configuration. So, all right, so there's one more command we need to run on this port channel, and that is the command that says VPC peer link. Okay, so VPC peer link is now going to it's like the magic command that will essentially make the last connection that ties all of what we just did together. So what we should see is, might need to give this a minute here. So it's going through the motions as we can see here. So when I first ran the command, it said peer link is down, but it kind of knew that the peer was out there, the peer's alive. So that's kind of where all these things, like, so it can reach the peer based on the VLAN 999 and the IP addresses that we assigned, right? But we had to tell the port that it was a peer link. We had to make sure that they were configured to allow 999, which we did the access port. So at this point, hopefully, okay, good. So now we can see when we run the verification command show VPC, we can now see that VPC domain ID 999, which is what we configured, we can see the peer status is the adjacency has been formed okay. So that's a great sign. We can see the peer is alive, and it does some configuration, consistency checks and all that good stuff. But what we're looking for is these successes, okay? We want to make sure that the port channel is up, that the VLANs are allowed, and we want to make sure that the adjacency's formed and everything's okay and successful. So this is a good sign. So show port channel summary. So we can see the old kind of legacy way to look at the port channel is still very similar. So we can see we've got port channel 1, passive, right? Like everything's good. But the key command for Nexus when you're doing VPCs is this show VPC command, okay? So we're in good shape there. So I'm going to do one more thing just because I think it's a neat command to do. You can configure aliases on Nexus, same as you do on iOS devices. So if I do CLI alias, and then I give it name, so this is what we want to call it. So I'm going to say write, or WR, and then this is the actual definition of what WR should mean. So I'm going to say copy, run, start. I'm going to end out. Now if I type WR, it'll actually do a copy, run, start, which is just kind of cool. I like it. Oops. So let's do that and right. So, all right. So at this point, we've got, let's go back to our topology. We've got core 1, core 2. And all we've done so far is we've configured the VPC domain 999, and we've tied 5, 6, and 7 together between the switches to enable virtual port channel ability in the future. So Next video, what we'll do is we will introduce the top of rack switch. We'll create what I'll call a legacy port channel from the top of rack's perspective up to the cores, which they'll consider it to be a VPC. So all we're trying to do is get port channel functionality between the top of rack to these two cores. So that'll be next video, and depending on time, actually no, we're not going to have time next video. We'll do the basic port channel configuration there, and then maybe we'll just configure the ports for the servers, and then we're going to have to start to get into the discussion of like default gateways and that type of stuff. So I'm going to stop here, and I will see you guys on the next video.